Today we're going to talk about radical expressions and rational exponents and how you can translate from one to the other, as well as what all of these different forms are. So let's just start with some square roots. I can write x to the 1/2 here, and this is the exact same thing as saying the square root of x all to the first power, which is the same thing as saying taking this first power here and bringing it inside. So it's the square root of x to the first power, which I could also then take this 1 and bring it out to the outside here and say that this is the 2/1 root x, or just the second root or square root of x. Now, this will make more sense as we get to this general sense with numbers that are not just 1s and 2s. So cubed roots follow the same thing. X to the, instead of 1/2, it's now 1/3. And then I can rewrite this as the cubed root of x all to the first power, the cube root of x to the first power, and the third root, or 3/1 root of x. So there's some patterns to recognize here. In general, if I've got x to the m over n, so 1/2, 1/3, m over n, then when I go to write it from an exponent to a radical, I'm just going to reverse the order of m and n. So instead of m first, then n, this is the nth root of x all to the m. So instead of m, then n, it's n, then m. Okay, this is also n, then m. The nth root of x to the m on the inside. And over here, the n over mth root of x. So the only time that you're going to have m, then n, m over n, is when you're writing it as an exponent. When you go to write it as a radical in any of these three forms, you reverse those. So let's do some examples. So here are my 4 different forms, and I'm just given a bunch of things to fill out. Let's say I've got 4 to the power of 2/3, 2/3. Well, I can rewrite this 3 different ways. I can rewrite this as the third root, the cubed root of 4 all to the second power. So that 4 stays in the middle, and then I just reverse the order of 2, 3, so it's now 3, then 2. This is the same thing as saying the cubed root, so the third root of 4 to the second power. So bringing that 2 inside, which is the same thing as saying this is the 3/2 root, and then 4. All right, let's say I start with this. The 7th root of x all to the 4th power. If I were to write this in this form, this would be the 7th root of x to the 4th power on the inside, or 7/4 root x. Then instead of 7, then 4, I can reverse it as an exponent and say that this is x to the power of, reverse these, 4/7. Okay, if I start with this 9th root x to the 5th power on the inside, that's the same thing as saying the 9th root of x all to the 5th power. Which is the same thing as saying 9/5 root x. And then reverse them. Instead of 9, then 5, I could say this is x to the 5/9. All right, a few more. We've got 3/7 root x. So this is the same as the cubed root of x on the inside here to the 7th power. Okay, that's on the inside. This is the same as saying the cubed root of x. Now this whole thing to the 7th power. And then I can reverse them. Instead of 3 then 7, I could do this is x to the 7 over 3. All right, with these last three, we've got some different things going on. So in this one, a is a multiplier. So I'm multiplying that to x to the 7/3. I'm not taking this whole thing ax to the 7/3. So what I want to do is I want to think of this a separately. So up here we saw this is x to the 7/3. And if I got rid of the a here, it would be exactly the same, x to the 7/3. Well, I got the third root of x to the 7th power. Let's rewrite that. Well, in this case, if I'm just multiplying by a at the front here, I'm multiplying by a at the front here. So this is going to be the only difference. Same thing here. So this will be cubed root of x to the 7th with a in front. 3 over 7 root x with a in front. Whereas the second to the last one here, now we see a isn't just at the front, a is with the x on the inside. So now what I'm going to do is instead of x, I use ax. So this will be the 4th root. And then on the inside, I've got ax to the power of y. Here, this will be 4 over y root, and then on the inside, ax. As an exponent, ax inside of parentheses, because they're together, then reverse this, instead of 4, then y over 4. And last one, I've got the yth root of x to the z. I know it's a lot of letters there, but I follow the same patterns as up here. So this will be, let's do this one first. This will be the yth root of x all to the z. This will be y over z root x. And lastly, x to the power of, instead of y then z, y then z, y then z, z over y. So there's a lot of different forms to these radical expressions, as well as how to write it as an exponent. And as you go across each of these rows, all 4 of these mean the same thing. All 4 of these mean the same thing, and so forth.